We're creating an FPS step climbing script that actually works and is really quick to set up. We'll go from no step logic to automatically and smoothly climbing any obstacle. If you want to skip straight to the working code, source files for this episode and next month's worth of videos are available to members. There's a link to that below. Currently, our player gets stuck against a step if the step is too high for the capsule collision shape to navigate. We're going to use a mix of collision detection and raycasts to smoothly climb our steps. Instead of getting stuck, our player will detect the collision, check for a vertical surface, raycast from above the collision point, compare step height to our set step height threshold, lift the player, and then smooth the camera transition. First, create a new component node and script. We need a reference to our player in the new step climbing script and a reference to the component in our player controller script. Our step climbing script's main function will loop through each collision of our player looking for vertical surfaces. We want to call this after the move and slide call in the player controller. Collision check is simple. We're just testing the collision normal's Y value. Y value of 0 means the surface is perfectly vertical, which we could then consider a step, but we're going to add some cushion with a threshold of 0.3. Running this presents a little bit of a problem. The curved nature of our capsule collision shape can give false readings. We can fix this if we use a raycast to double check our work. In our script, our check collision normal function becomes isVerticalSurface, and we'll flip our logic here and check if our absolute normal Y value is less or equal to our threshold. If it is, we'll consider it a vertical surface and move on. If not, we need to do our second check with check collision surface. In this function, we'll manually do a raycast from the player's feet to our collision point. This gives us a diagonal line, however, and we want to cast horizontally. So we set our collision point Y value to our player's feet Y value. Our player's feet value is set by another function, getPlayerFeetPosition. That gives us our feet position based on the player's height plus a small added height so we're not casting from within the floor. When we cast our ray, we also need to exclude our player so we don't collide with ourselves and match our player's collision mask. When our ray collides with our original surface, it now does it at a consistent angle, so our normal reading is also consistent, and we no longer will get false negatives. Once we know we have a vertical surface, we need to know how tall that surface is to determine if we can step up. We add a check for a measured height of our surface. If that height is greater than 0 or less than or equal to our step height, then we'll consider the obstacle a step. To get the measured height, we cast another ray from the X and Z position of our collision point, starting at the player's height to the player's feet Y values. Think of this as a line going from the top of the player to their feet, passing through the collision point. This line gives us the first collision along this vector. By subtracting the player's feet global Y position from our result, we get our step height and can now check if it falls within our step range. Now that we know what is and is not a step, we can move the player over it. The most basic version of this is simply teleporting the player to the height of the step so they can continue moving forward. Lifting the player is the easy part. We just add the measured step height to the player's Y position. The hard part is when you run into edge cases where the player has a valid collision, but we're not actually trying to step up, like when the player is walking along a step or on the edge of a ledge. So let's save you hours of debugging and get directly to the fix. Instead of relying only on the collision and the raycast, we add another Boolean check isValidStepDirection and check if our input direction is close enough to our collision normal. Notice the getInputDirection helper function that we add to our player controller. To be safe, we can also eliminate any step checking if we are in the air by only running our step handler when we're on the floor. Use a dot value comparing the two, and when the dot value is greater than 0.5 or the difference in vectors is less than 60 degrees, we'll consider the player moving in the same direction of our step and can continue with our step handling. Additionally, if the player isn't moving, then we won't try to climb anything. This check for movement direction eliminates the jittering on the edge of ledges and moving along walls. I've also added a minimum height check because the capsule shape handles heights less than 0.1 pretty well, so we don't need to worry about any heights less than that. Right now we have a decent solution for our steps, but we can still get rid of the sudden visual jolt that happens, which we can do by smoothing the movement of the camera. If we encounter a climbable step, we run a new function, smooth step, in our camera controller script. This function will set a target height for our camera controller that will immediately offset the height of the step. While our target height is greater than 0.01, we lerp it back to 0 while we smooth. Once it's below that threshold, we set it to 0 and stop smoothing. We have decently smooth movement now, except for two issues we need to fix. Crouching messes with the offset height, and we still get a short jolt because of the run tilt effect we created in the last episode. Our player's momentum actually stops on collision, which causes the run tilt jolt. The fix is actually pretty simple. We just save the previous frame's player velocity and set our player velocity to it when we encounter a step. This will keep the player moving in the same direction and then eliminate the jolt. The crouch issue is fixed by using an offset height that will default to our camera controller position offset, 0.5. and change when we crouch to 0.0. This can be set whenever we enter the respective states, crouching and standing. Finally, we set the Y position of the camera controller to the offset height plus our lerped target height. We can now run our script through the step gauntlet and see that it handles everything smoothly. Next episode, we're integrating Trench Broom with Godot for rapid level design. You can grab the source files for this by becoming a member. These include the complete optimized step climbing system, plus Trench Broom setup, and the next 2 episodes releasing over the next month. Thanks for watching, I'll catch you in the next one, and until then, keep creating.